Hello everyone. Today in this section 8.3 I'll be talking about ellipse. This is another conic section that we'll be covering in our chapter 8. So let's start with the definition. Given 2 points, say F1 and F2. Okay. Let K be a positive number such that K is greater than the distance from F1 and F2. F1 to F2. Okay. Then we define the ellipse this way. And the ellipse is a set of all points P satisfying distance from P to F1 plus the distance from P to F2 is equal to K. Okay, that is the definition. Let me try to explain to you guys what it means by that definition. So pretty much you are given 2 points, F1 and F2, and we can learn from the previous section of parabola F stands for focus. So in this problem, in this section, we have 2 foci, F1 and F2, all right? And of course, this is a distance from F1 and F2, and K is just a positive number, and K gonna be greater, right? So the value of K is longer than the distance, it's bigger than the distance from F1 and F2, okay? So how do we define the ellipse? We try to find all the points P such that the distance from P to F1 plus the distance from P to F2 equal to a constant K. Alright, now you see why we need K to be longer than F1 and F2, right? If K is equal or smaller, then we don't have the point P. We don't have the ellipse. So, and you know what? We have a lot of points P that satisfy the condition of what? The total of the two distance measurement from P to F1 plus P to F2 equal to K. We have a lot of points. Alright, and if you connect all the point P together, let me draw it a little bit better. We're going to have something called the ellipse. Okay, so the ellipse looks like this. Okay. Okay, so any points P on the ellipse, if you want to find it, if you calculate the distance P to F1 and you add distance P to F2, will have one common property. It's equal to a constant K all the time. Doesn't matter where you plot P. Okay? We have the same total distance. Okay, that's the definition of the ellipse. Now let me show you some ellipse equation. And I claim that the way I'm approaching the ellipse equation is a little bit different from the book, even though the main idea is exactly the same. You can either learn from the video clips or you can read the book by yourself and you can see the difference, because I've just used different letters and different notation to approach this. Pretty much it's the same idea. Okay? So, number 2 equation. Basically, in our section, we'll learn 2 types of ellipse. This one right here, we're going to call the horizontal ellipse. And this one right here, we're going to call the vertical ellipse, okay? Either vertical or horizontal ellipse. Instead of giving you guys 2 different formulas or 2 different equations like the book, I'm going to give you just one formula that satisfies both cases, okay? And the equation that I want you to know is this: x squared over a squared plus y squared over b squared equal to 1. I'll try to be consistent on the about A, B, where A and B is just really numbers, okay? A will always go with X for me, B will always go with Y for me, so I'm not going to change those, okay? And A, B is just number, okay? Positive numbers. And this is the equation that I want to show you. Let me write up here small so I have some room to write. X squared over A squared plus Y squared over B squared equal to 1. So both A and B is a number, and I always write A goes with X, B goes with what? The first case, if A is bigger than B, so the number associated with X is bigger than the number associated with B. In other words, the X is longer than the Y, okay? Think of it that way. Then I claim that we're going to have the horizontal ellipse, x-axis right here, y-axis right here, okay? This equation where A is bigger than B, down here. From the center, from the origin, let's go to the right A unit, go to the left A unit, so this is negative A, positive A, go up B, go down B, so we've got B and negative B, and since in this case A is bigger than B, so you go left or right further than you go up and down, okay? And I claim those 4 points of the vertices of the ellipse, and your ellipse is going to be like this. Okay? So far, so good. And the longer diameter, so it's got a major axis, it's going to be horizontal one. Alright? And the minor one going to be the vertical one. So, because this one is V1, this is the vertex number 1, this one called V2, vertex number 2. Okay? And center right at the origin right here. The two foci, F1 and F2, will always stay on the major axis. So it's going to be F1 somewhere in here, F2 somewhere in here. At this point V1 is at negative A comma 0. The point V2 is at A comma 0. This minor vertex right here, up here is 0 comma B, and the point down here is 0 comma negative B. Some book denoted by lowercase v1, and this is lowercase v2, but I didn't see it in our book, so I'll just give you the point without a name. Okay? And our tradition to denote the distance from the center to the focus at C. So this point right here at C, and this is negative C. So F1 at negative C comma 0, F2 is at positive C comma 0. Okay? Are we good? And the relationship between A, B, and C is we have the Pythagorean theorem. Okay? We have, and here the longest side is A. So A is going to be the hypotenuse. So A squared is equal to B squared plus C squared. In other words, C squared is equal to A squared minus B squared. Just simply take the longer one, subtract the shorter one. Okay? Example. X squared over 4, make it like 4 squared, and 4 squared plus y squared over 3 squared. How about, let me write this way, 4 squared is 16, 3 squared is 9, okay, equal to 1. So in this example right here, I'm giving you an equation for the ellipse, where A here equal to 4, and B here equal to 3, because what, 4 squared is 16, and 3 squared equal to 9. Alright, so obviously A is bigger than B. So the value goes with X, bigger than the value goes with Y. X is going to be longer than Y. We have the horizontal ellipse. So we want to sketch a graph. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3 up. 1, 2, 3 down. The ellipse is going to be this way. Okay. 2 foci are going to be on the left and the right. How do you find the 2 point F1 and F2? Oh, by the way, this is V1. Is that negative 4 comma 0. V2 right here as 4 comma 0. Okay. And we have the formula for you guys to calculate. Just simply take the bigger one and subtract the smaller one. So C squared is equal to A squared minus B squared, which is 16 minus 9 equal to 7. So C is equal to square root of 7. Okay? Now square root of 7 is 2 point something. F2 is somewhere right here. F1 is somewhere right here. Okay? So the two foci is F1 is at negative square root of 7 comma 0, and F2 is at square root of 7 comma 0. Okay? So this is our first equation and the first example about the horizontal ellipse. Now I'm going to move on to the second type, the vertical ellipse. And of course, as I mentioned before, I'm going to stick with the same formula. So I'm not going to give you another equation. Okay? In the book, it's with the letter. The second equation they're going to give you x squared over b squared plus y squared over a squared equal to 1 to indicate that now the a value is on the y, a is always bigger than b. But I'll just stick the same formula, but I'll write this way. Second case is a is less than b. Okay? Then you're going to draw the same thing, x-axis, y-axis, a always go with x in my lecture, so I start from the center, go to the right, a unit, go to the left, a unit. Now a is less than b, so b is going to be bigger. Go up and down b, you got b and negative b, you're going to have the same type of ellipse, but now b is bigger than a, so the ellipse look vertically. Alright? And as I say, the two foci F1 and F2 will always stay on the major axis. So it's going to be on the horizontal line now. The V1 is going to be up here this time. So V1 now is at 0 comma B, and V2 is down here at 0 comma negative B. Alright, and we always use C for the two foci. So this is C, this is negative C. So F1 is at 0 comma C. F2 is at 0 comma negative C. Alright, and how do we calculate C? The same way, always take the bigger one, subtract the smaller one. This time B bigger than A, so C squared now is B squared minus A squared. Okay, another word, the B now is the hypotenuse in the right triangle. Okay, so example, think of this, x squared over 9 plus y squared over 25 equal 1. So this time, in this example, a equal to 3 and b is equal to 5 because 3 squared is 9 and 5 squared is 25. And let's guess the graph. X-axis, y-axis. So a is 3 from the center. We go to the right 3 unit. We go to the left 3 units. Okay, so negative 3 here, 3 here. Go up 5, 1, 2, 3, 4, 5. Go down 5, 1, 2, 3, 4, 5. Okay, you guys have an ellipse. Okay, at this point, vertex V1 is at 0 comma 5. V2 is at 0 comma negative 5. Alright, and how to calculate the two foci? We calculate C. We know that C squared is bigger, subtract smaller, so 25 minus 9 equal to 16. So C is equal to 4. So the two foci here, F1 is at 0 comma 4. F2 is down here at 0 comma negative 4. And pretty much that's everything about the ellipse center at the origin. And like the way that we talked about graph last time, what if we want to have a more general formula instead of having the center right at the origin? Okay? What if we have a center at a random point, say HK? We're going to approach this the same idea. This graph right here, center at the origin. Okay? What if you got the center of the ellipse at H comma K? How do you move? You change X to X minus H. You change Y to Y minus K. You shift the X and Y coordinates of the center to a new point. So the general equation will be X minus H squared over A squared plus Y minus minus k squared over b squared equal to 1. Okay. Now let me show you some examples, maybe one, maybe two examples about the ellipse, and you guys see the whole thing out of it. Alright, this is the general formula for ellipse, center at hk. Okay. Number 3, examples, exercises. Alright. First one, give you this. X plus 1 squared over 4 plus y minus 2 squared over 9 equal to 1. Okay? You see this an ellipse? Is that vertical or horizontal? A is 2 because 2 squared equals to 4. B is 3 because 3 squared equals to 9. So B is bigger than A, or the y values. The number goes with y, bigger than numbers goes with x. So y bigger than x is going to be the vertical ellipse. Okay? And you know where the center is at? Center is at -1, 2. H is -1 and y is 2. Okay? And with that much information, I claim we are good enough to sketch a graph of the ellipse. Alright, let's sketch a graph together. X-axis, y-axis, 1, 2, 3, 4, 5 negative. And 1, 2, 3, 4, 5 positive. Portion right here, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, -1, -2, -3, -4. Okay, first of all, we start with the center. The center is at -1, 2. -1, 2 is right here. Okay, x is -1, y is 2. So this is my horizontal axis, and this is going to be my vertical axis for the ellipse. Okay? And now from the center, I'm going to go left and right 2 units. Okay? Go to right 2 units. Go left 2 units. Okay? From the center, B is 3, so I'm going to go up and down 3 units. 1, 2, 3. 1, 2, 3. Go down 3 units. Okay? And this will be my ellipse. Let me use red color to make it stand out. Okay. This vertex V1. This is V2. V1 is at x is -1 and y is 5. V2 is at -1, -1. Let's just answer the question. How do I figure out the V1 and V2? We start from the center, guys. This is always start from center. See where the center is at. Center is at -1, 2, right? And how did I get to the two vertices, V1 and V2? I move up and down. How far? 3 units, right? So this is the x coordinate, this is the y coordinate. I'm not going to change the x coordinate because I keep the same x coordinate values. I'm just going up and down. Okay, I didn't move left and right. So how far did they go? Up and down 3. So the vertices you're going to calculate by what? Vertices is going to be what? -1, 2 plus or minus 3. Where did I get number 3 from? This is the b value where I move up and down. Okay, so I'm going to have 2 values in here. V1 is at -1, 5, and V2 is at -1, -1. 2 plus 3 is 5. 2 minus 3 is -1. That's why I got the 2 vertices. Similarly, I can calculate the 2 foci, F1 and F2. Okay, let's start with C. I know the C squared, and this example, to take the bigger one, subtract the smaller one. C squared is 9 minus 4, and this is equal to 5. So C is equal to square root of 5. And I think square root of 5 is 2 point something. So from from center right here and go up 2 point something. This is F1, go down 2 point something, I got F2. Okay, so how do I figure out the 2 points? Do the same from here. I got center at -1, 2. All right, calculate the focus. The two foci F is what? -1, 2 plus or minus square root of 5. Okay, because I move up square root of 5, move down square root of 5 from the center. So I got two foci. F1 is at -1, 2 plus square root of 5. 2 plus square root of 5, 4 point something. Okay, and F2 is -1, 2 minus square root of 5. 2 minus square root of 5 is -0 point something. I got everything about the ellipse. There are actually more about the ellipse, but our textbook didn't mention much. We have the directrix line. Now the ellipse is going to have two directrix lines, one above and one below in this case, and we have something called the eccentricity. Okay, but at our level, the book just wants you to know that much, so I'll just show you that much. Let me show you one more example of ellipse, and I'll stop the video clip right here. Okay, one more example. What if you see something like this? X minus 2 square about times 4 plus 9y plus 3 square equal to 36. Alright, now we don't see fraction, we don't see equal to 1. We gotta modify our equation a little, make it look like ellipse. And the step that we're gonna do here is simply divide both sides by 36. Divide both sides by 36. By 36, you have 1. Okay, so simplify, you got what? X minus 2 square over 9, take away 4 from the top and the bottom. I got 9 left in the bottom. And then for y, take away 9 on top and the bottom. I got y plus 3 square over 4, and of course equal to 1 on the right hand side. Now it looks like the ellipse. Okay, in this case, A is equal to 3 and B is equal to 2. Which one is bigger? This time, the value associated with X, 3 is bigger than the value associated with Y, which is 2. So X is bigger than Y, you have the horizontal ellipse. Okay, and we can actually calculate C right away. C squared is equal to 9 minus 4. See what I've done? Just take the bigger number, subtract the smaller one. So 9 minus 4 equal to 5. So C is equal to square root of 5. Okay? They're all positive number, A, B, C. Okay, now let's guess a graph of the ellipse. Okay. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8. We start with the center. We know that the center is at, this is big C for center, okay? This is small c for the coordinate of the focus. Big C is what? 2, -3. You guys see where I got those two numbers from? X minus H, Y minus K. So H is 2 and K is -3. So we start with the center. 2, -3. Right here. This is the center of the ellipse. Alright, so from the center, we have the horizontal axis. We have the vertical axis. And A is 3, so move to the right 3 units. Go to the left 3 units. Alright, B is 2. So move up 2, move down 2. It's going to be our ellipse right here. You guys see we have the horizontal one, right? Center is this point right here. 2, -3. And the 2 vertices now on left, right, right? B1 here, B2 here. So center is at 2, -3. Yes. And to find the 2 vertices V1 and V2, Now we have to move left and right, so we have to add and subtract a number to the x-coordinate. So 2 plus or minus. How far do we move left and right? 3 units. So 2 plus or minus 3, comma, negative 3. So we got V1. Now let's subtract first. So we got V1 is at negative 1, negative 3. 2 minus 3 is negative 1. Right here, this point. This is negative 1 and negative 3. And V2 is at 5, comma, negative 3. 2 plus 3 is 5. This is 5. 5, negative 3. Okay? Same thing for the 2 foci. Instead of add and subtract 3, this time we're going to add and subtract square root of 5. So the 2 foci F is going to be 2 plus or minus square root of 5, comma, negative 3. So I got F1 is at 2 minus square root of 5, comma, negative 3. And F2 is at 2 plus square root of 5, comma, negative 3. Alright. Pretty much those are typical examples about the ellipse. Hopefully those helps. Alright. I'm going to stop the clip right here. Have any question, please ask. Thank you.